Hello, everyone, and welcome to today's panel session brought to you by Oceanology International Middle East in partnership with Unique Group. Oceanology, a bit of brief about Oceanology International Middle East. It is our new addition to our global oceanology portfolio. The show was scheduled to happen this year in Abu Dhabi. However, due to the current situation, we've decided to reschedule OIME to next year. It will take place in September in Abu Dhabi National Exhibition Center. Today's webinar will be followed by a quick survey. The purpose of the survey is to understand better your business needs in current market situation. We are absolutely delighted to have top experts with us today, and I would like to thank Unique Group for assisting in organizing the webinar. I will leave the introduction to be done by today's session moderator, Nick Lambert. So without further delay, over to you, Nick.
Thank you very much indeed, Faraz, and good afternoon, ladies and gentlemen. A real privilege to be here speaking to you with a panelist team that I know well and with some wonderful technologies to talk about. David, would you please put up the first slide and click onto the agenda? Ladies and gentlemen, we've had a few bandwidth problems, so you'll just have to bear with us as we go through. Please do comment through on questions if you're having any problems. So I'll shortly give an introduction to our panelists, and then we'll go through the agenda bullets that are provided here. The idea being to give you an understanding of just how far ahead companies such as Unique Group and iXblue are with pushing the technologies in the world of survey, offshore inspection, and so on. So just a couple of domestics before we go on. Faraz kindly mentioned the survey, which I'd be very keen for you to complete, and I'll be reminding you again as we go through. Please do ask questions as we go through. You'll hear me questioning the panelists, so please put your questions up and I will incorporate them into the discussion, and there is a chance for Q&A at the end. And I should also point out that we've provided a pack of about 40 slides, and thank you very much indeed to our panelists for doing that. We're not going to show you all 40, several of them are hidden in the interests of time, but the pack will be available for you on completion of the webinar. So please don't forget the survey, please ask the questions, and do go through the agenda pack, the pack of slides on completion. And next slide, please, David. Thank you. So, ladies and gentlemen, our panelists. Trevor Hughes, I've had the pleasure of working with over several years now, particularly with Oceanology International before he came to Unique Group. He has a great experience in oil and gas. David Rennie, also of Unique Group, you'll hear him talking about some of the issues concerning the use of their technology. Olivier, thank you very much indeed for standing in for Guillaume at short notice, but what you don't know about iXblue and your wonderful technology is not worth knowing. And Peter Collinson, who's now an independent expert, but has spent a considerable period of time with BP, and we'll be talking to you about the issues of transforming a big corporate and getting them to think about how to use marine autonomous systems, robotics, and USVs. My own position, I set up a blue economy company about 10 years ago. That's about 22 of us, and we spend our time working on projects across all of the sectors we're going to talk about today, plus a few extras. So with no further ado, our panelists, thank you very much indeed, gentlemen. Next slide, please. So this is my chance to introduce unmanned surface vessels, unmanned survey vessels, marine autonomous systems. There are a multitude of different terminology out there. Autonomous underwater vessels, UAVs, you've heard them all before, but just think autonomous systems operating in the marine environment and supporting maritime operations. Next slide, please, David. And just to provide you with an overview, ladies and gentlemen, very much my experience, my opinion. I'm relieved that every now and then I hear somebody else saying a similar thing, which makes me think I might be on track. And I think the biggest fundamental factor which is coming into our lives today is climate change. It is now geopolitical. You'll all have been watching the news recently with the COVID saga, but climate change is still there. And in particular, Generation Z are now alive to climate change and very acutely aware of the environment generally and the marine environment in particular. And just to keep things simple, the marine environment, when we refer to it today, it's all about the natural capital of the water column, the seabed, the airspace above and where it coincides with the land, the coastal zone where people live, and maritime operations, anything that human beings do at sea. From my point of view, the technological planets are now aligning. We've really got some exciting platforms out there. iXblue, unique platforms we're going to talk about today, but there are many others, and it's really pushing the boundaries of what can be done with platforms. Sensors are coming on in leaps and bounds. They're cheaper, they're smaller, they're better. Connectivity is improving. There's a massive Wi-Fi network, for example, right the way across the North Sea, and I think there's a similar one in the Arabian Gulf. And computing capability, our ability to crunch big numbers is growing all the time. It's so exciting, and quantum computing, quantum technology coming on in the next decade or so. So these technological planets are aligning. And the result is that there's a growing interest in the blue economy and blue growth. And many countries around the Middle East have their own blue economy strategies and blue growth plans. And these are designed to extract the socioeconomic benefits of the blue economy across a range of different sectors. Lots of the new sectors, aquaculture moving further offshore. We've seen everybody talking about the benefits of seaweed. Using the resources of the water column in a more imaginative way, but at the same time balancing it with improving our understanding of the marine environment by data gathering and sharing, and putting in place regulation which allows us to get the economic benefits whilst minimizing the damage to the marine environment. The result of this growth in policy over the last 10 years, I would say, is we're now seeing the increasing awareness of investors. I wouldn't say it's a tsunami of activity at the moment. I think I stole that word from somebody else earlier today, but it's certainly a clear indication that investors, funders, insurers, accountants, banks are beginning to wake up and see that if they look across the coastline, there is opportunity out there. Seabed 2030, I'll come on to that in just a second because there's another slide, and regulation. We'll talk about regulation in a bit of detail because, needless to say, it lags behind technology and can be seen as a barrier as well as an enabler. And we'll talk about that in a little bit more detail. But hopefully, David, if you click to the next slide, we should see a Seabed 2030. Thank you very much indeed. Something I'm particularly passionate about is the ex-UK national hydrographer. The Nippon Foundation recently reinvigorated the Seabed 2030 project under the auspices of the International Hydrographic Organization. And for those of you who haven't heard of it before, GEBCO is the General Bathymetric Chart of the Ocean. And the ambition of Seabed 2030 is to map the world's seas and oceans to a resolution of 100 meters or better by 2030 and make that data freely available across the globe for whoever wants to use it. So that will provide a base layer of data on which initial planning can take place and more focused surveys and so on can be established and commissioned for whatever purpose it might be. I mentioned aquaculture, it could be seabed minerals. I know that gets all sorts of debate running. It could be marine biopharmaceuticals, it could be leisure and tourism. Very, very ambitious project, hell of a stretch target because only 20% of the ocean floor has been mapped to 100 meters resolution or better. So we've got 9 and a bit years to do the remaining 80%. So there's all sorts of opportunities out there, and the sorts of technology we're talking about this morning are perfectly suited to this, both I would say in deep water and shallow water being one of the most difficult places to operate and to survey. Next slide, please. So with no further ado, I'd like to call on Peter Collinson to say a few words in his perspective, having recently become independent and looking back to BP. And I've asked him to look into his crystal ball, as indeed I will my other panelists as we get a little bit further. into the debate. And ladies and gentlemen, no questions yet. It's early in the days, but please don't forget to put some questions up in the chat room. Peter, the floor is yours. Thank you very much indeed for joining us.
Thanks so much, Nick. Thanks for the opportunity to present today, and thanks for everyone who's joining the webinar today. I wanted to start with the idea around, where do we see unmanned systems going by 2025? And it's one of the main questions that I'm asked often. When is this all going to be real? Well, to set context, back in 2018, when I was working for BP as the head of maritime autonomous systems there, I stood up at a conference in the UK and proclaimed that, by 2025, 100% of all subsea inspection will be done using unmanned systems. Now, at that time, 2 years ago, which from a technology perspective feels like a lifetime ago, we didn't have answers. Companies like Unique, weren't offering services around maritime autonomy. iXblue was a new kid on the block as far as BP was concerned. And we put this aspiration out there. We called it a moonshot, hence the picture of the spaceman there. And it was really to try and stimulate the market. So we had unmanned systems that could be used. I still firmly believe that 2025 and this aspiration is absolutely right. And I think what's great about the presentation today with iXblue and Unique is that, companies are offering proper services now that we can use. I'll use the term boring is good. If we can use unmanned systems to deliver everything that we think that they can do in a way that we believe can be done, then this will become normal business. And, we're very, very excited. And certainly in my role at BP, I was excited and continue to be that these provisions of unmanned systems, both on the water and underneath the water, will actually transform our business. Now, I mentioned here about subsea inspection. What I would also do is extend that through to survey, because in essence, what we're doing with inspection, it's very similar to how we would think about survey, and that most of it is around what I would call passive acquisition of data. So we're not picking things up or twisting valves. It's using sensors to acquire data that informs us, whether it's for survey, for a whole bunch of different aspects that you look at, for site characterization, or also inspection, where you're looking at a much closer level, I would say, at infrastructure. Could we jump to the next slide, please, David? Thank you. So this slide here really gives you some of the areas of value that I believe are offered by unmanned systems. And this belief is based on real development of these systems and real testing of them over a period of about 5 to 7 years. So very briefly, one of the main benefits here is around carbon emissions reduction. From my own experience, when we run these unmanned systems, we're looking at a greater than 90% reduction on carbon emissions over traditional crewed vessels. Why? These vessels are smaller, they don't use as much energy, and they don't have people on board. So, they're smaller format, they're a bit more agile, but the data quality is the same, if not better, which is really, really sings the benefits. Safety, obviously safety is paramount in the energy sector, as it is for any sector and any maritime sector and business. So primarily, we remove people from hazardous environments by having 0 people at sea through operating these systems. And also, because these systems are often smaller and don't have people on board, then actually we have a reduced operating risk. In as much as, we don't have large, heavy vessels getting very close to, manned platforms or manned rigs. These systems are a lot smaller. So the consequences, and one could argue the probability of a risk or a collision or something happening is much reduced. So there's a definite safety benefit there. On the cost side, these are smaller systems. They're agile, and you could argue have a very good persistence at sea as well. So actually, they come in at a smaller cost because of their more compact size and format. But also there's a lot of value around the data there. If we automate the data processes, then actually also we get cost reduction through the data and that value of the data. And then lastly, something that's often overlooked is the skills piece and the people aspect. I think marine autonomous systems actually does attract people to the companies that operate marine autonomous systems, because the skills in robotics, in remote operations, in analytics, these are all what employees want, for future-proofing their careers and building their careers. So it's an attraction. I think the other factor as well is that it can also recruit new talent into, for example, the energy sector, because these systems are new, they're exciting, but also it allows you to remotely operate them. So people who perhaps couldn't have got on a vessel and gone for 4 weeks at sea can actually operate a vessel for 4 weeks at sea, but do it from the comfort of an office. And that opens up the diversity of talent that we can bring into the sector. So I'm really excited about about marine autonomy. I think the main thing is using it and learning for yourselves the benefits and the value of these systems. And I think we're now entering a phase where these are now commercial services, as we will learn in this talk through Unique and iXblue. Proper systems that really work and do the job well to a very high quality, with high reliability. So my clarion call at the end of this slide is give it a try. Start small, start large, but give it a try and be aware of the benefits and learn the benefits of these systems.
Thanks very much indeed, Pete. I mean, I just love your enthusiasm. I've listened to you for many years now. Could you just click back one, please? I love your enthusiasm for the autonomous systems, and it must be really challenging to get the change of mindset in a big corporate in the way that you did. I also enjoyed your linkage between subsea, so seabed survey and inspection roles. Can you just talk briefly about whether you see business models changing? Do you see partnerships changing? And also, how do you make the numbers stack up? Because generally it comes down to P&L in corporates. So perhaps you could just comment on that as well, please.
Thanks, Nick. So I think what I anticipate seeing is that we will see these maritime autonomous systems actually become what I would call multi-mode. So, they will be able to conduct surveys, they will be able to do inspections, they will be able to harvest data, they will be performing a variety of different roles. And I would say we know what some of those roles are, but I would also argue we also don't know what some of those roles will be, because, we are genuinely, I think, on a learning process about transforming the business to an unmanned robotic system. So I think, in that sense, Nick, the business models are being, I'll use a non-technical term, mashed up. That what we may see is a simplification of the user groups, literally, quote, calling off for data. So we may go to a data as a service model where, energy companies, they don't need to be involved in the logistics of getting a vessel to the location. They don't need to be involved heavily in the operation of the unit minute by minute. They simply dial up a package of data that they require, and then it is seamlessly delivered. So I see that's how the market may change. And also with that, there's a huge amount of cost efficiencies, or actually I say efficiencies rather than cost, because I think the discussion is around value rather than cost in a way. So I think, we will get more value from these multi-mode systems in the future, which coming to the profit and loss and bottom line, has a very positive effect.
Yeah, thanks. And I think that terminology multi-mode is a really good one. And I mentioned deep water survey, which is clearly a major task, but most of the complex sea basins, that the areas where blue economies are kicking off and countries are bounded on, are sub 200 meters. And the sorts of technologies we're talking about today are ideally suited for multi-mode tasking across those environments, and hopefully the cost will come down. Gentlemen, you'll be pleased to hear that the questions are coming in from our attendees. One person has asked about the pandemic. We'll cover that question in a moment, if I may. But there was another one on GEBCO, and it says, how does GEBCO support marine survey companies to acquire the data? Do companies do it at their own cost, or does GEBCO support financially? Very, very good question. I think that and this is my personal opinion, I think that we're going to see a range of different means of providing data into the Seabed 2030 project. One will be through crowdsourcing data, and we're already doing some trials on that. And there's a lot of thinking to be done about how that is done at minimal hassle and expense for those people who are prepared to do it. Do companies out there have data sets that are sitting in a cupboard somewhere that could be contributed into the database? We ran a questionnaire the other day and we got quite a lot of correspondence and response to that, offering data sets. And thirdly, I think I mentioned 80% of the oceans to be surveyed by 2030. Clearly, that is not going to be done on a crowdsourced or voluntary basis. There's going to have to be a prioritized survey program, and there's going to have to be some sort of funding for it somewhere. So I think we will see commissioned surveys to rolling out in priority areas. Who pays for those surveys is another matter. There's going to be a lot of fundraising activity, particularly amongst NGOs and not-for-profits, as well as philanthropic and government organisations. So watch this space. Any questions on GEBCO, please do feel free to contact me separately. And later on, ladies and gentlemen, we'll provide the contact details of the panelists so you can approach them independently. So Peter, thank you very much indeed for those interesting that interesting overview. David, please go to the next slide, if I may. So now a little chance for us to ponder on the relative benefits and capabilities of remote and truly autonomous operations. Next slide, please, David. Thank you. And David, I think this is for you in any case. So the floor is yours. Thank you for joining us today.
Thank you, Nick. Yeah, so there are three sort of definitions for unmanned vessels. You have remote vessels, remote controlled. These vessels are unmanned but operated by a human who's in full control of everything the vessel does. And these are generally the simplest control systems. They're often used on smaller, low-cost, low-logistics surface vessels that are doing performing tasks close to the operator, close to a mothership or close inshore. Then the sort of gold standard are the autonomous vessels. These vessels are capable of operating completely without human oversight, with the vessel's autopilot decision making all the operational command decisions. And these systems are often seen in equipment like the oceanographic sea gliders that run missions lasting months and spend much of their time submerged. And that works okay with those. They've got relatively small data sets. The data they're acquiring at small file sizes, they can store that for months and then surface at the end of their mission to be recovered and get the data ashore. And then the in-between one, supervised autonomy, and this is where most of the systems really lie in this area. And these vessels have varying levels of autopilot, enabling them to perform some tasks, things like line keeping automatically. And they have a human operator monitoring them who can also occasionally instruct the vessel. And they generally provide a real-time QC feed of data that's being acquired. So these are particularly useful for if you're doing hydrography. Bathymetry data sets are notoriously large, and there's a lot of risk if you send a vessel out autonomously and have no sort of monitoring of what it's acquiring, and then you get it back 3 days later and find you've missed chunks of your survey. So these allow QC and intervention in the missions in response to the results acquired, used for most commonly in hydrographic and geophysical survey. And the DRIX is an example of a vessel with supervised autonomy. You can get full control of the data set and full access to it as you're running and acquiring data. And there's a regulatory issues surrounding these, the regulatory challenges surrounding these. There's definitions of autonomy that the IMO have. They stick with four broad definitions of autonomy: ships with automated processes and decision support but have seafarers on board, remotely controlled ship with seafarers on board, a remote controlled ship without seafarers on board, and a fully autonomous ship. The major classification societies like Lloyd's Register and Bureau Veritas and DNV, they're discriminating a bit further between whether everything's remotely controlled, whether the vessel suggests course of action which then get authorized, or whether it has full autonomy itself. So some of the regulatory challenges that exist, the integration of USVs within or mass within the existing sea traffic regulatory system is really quite tricky because it's been developed for manned ships primarily. So there's a lot of references to crew on board and requirements that stipulate the actions that these people have to undertake and the qualifications that they have to have. So there's no universal internationally applicable definition of ship. It varies from nation to nation, and there's different national laws including different criteria concerning shape, size, purpose. Whether or not a particular regulation applies can really only be answered with respect to specific USV and in relation to the specific national environment that it's operating in. And some states have got different definitions for the term ship across their legislation, so that there could be multiple definitions. This means a USV could be a ship, regarded as a ship in the purposes of one of the laws, one area of legislation, and then not as a ship in other areas. There's also the marine regulations such as SOLAS. This normally applies to ships of at least 500 tons. There is some flexibility within SOLAS where it could potentially be argued to apply to USVs. And there's 5 categories of ship under SOLAS regulations: a passenger ship, cargo ship, tanker, fishing vessel, and nuclear ship. And cargo ship has an open definition of being any ship which is not a passenger ship, so in theory could apply. But this 500 gross ton limit really means most, certainly unmanned survey vessels, are generally below that level. So SOLAS, strictly speaking, won't apply beyond the general duty of care requirements that any vessel at sea has. And call regs is another grey area. They apply to watercraft capable of being used as a means of transportation on water, and that can be argued doesn't apply to USVs, which are not transporting anything or transporting any people. They've neither cargo nor personnel on board. However, some aspects of COLREG, they have specific referral to vessels that are restricted in their ability to manoeuvre, and often a USV, depending on what it's doing, if it was towing anything, it would have that sort of restriction. So COLREGs could be argued to apply there. And the IMO have decided not to update COLREGs at this stage. So there are a lot of references throughout COLREGs for referring to, Part B covers the conduct of the steering and sailing rules, and that requires watchkeeping standards, and it references made to personnel on board. So the typical approach USV manufacturers have taken, and the DRIX has done this, is they have surround sound cameras, so they have visibility that the remote operator can get a vessel's eye view of the surroundings. Some of them, like the DRIX, have automatic collision avoidance systems as well, all in an attempt to make them conform to the spirit of COLREGs, even though COLREGs themselves are not written with USVs in mind. And there's the STCW requirements for competencies, and they refer to seafarers serving on board seagoing ships, which again, that doesn't apply to USVs directly, but the best practice guidance of things like the Maritime UK Mass Code of Practice, they recommend that whoever is operating the USV has the required certification for that class of vessel. So, for example, in the case of the DRIX, that would be something like a powerboat level 2 ticket, which enables them to operate up to 20 kilometers from safe haven, and that's been used the safe haven's been taken at times to be the mothership to enable them to work very far offshore. So there's a lot of grey areas. There's very little certainty. The IMO's Marine Safety Committee is undertaking a regulatory scoping exercise at the moment. It was meant to be being concluded earlier this year, but COVID has intervened and caused some delays with that, and they're still expecting to complete in 2020. But really, we need some certainty to start defining these regulations, so we get some consistency. So that's it's very much a grey area at the moment.
David, thanks very much indeed for that comprehensive overview. And regulation is always a thorny issue. We could spend the entire day talking to. I think you've given a great overview there. And ladies and gentlemen, there are additional regulatory slides in the pack that are hidden, which you can see afterwards. And for the lady or gentleman who asked, will the presentations and attendees contacts list be available at the end of this? They will indeed. And Ria is about to just put up a slide to remind you for the survey, please. The gentleman or lady who asked the question on GEBCO and has followed up, please do come back to me privately on my email, because I'd be very interested in talking to you about it further. But just before we close out on regulation, I do want to ask follow up on a question that's come in on standards, which I'll put to you in a second, Peter. I'd like to go to Olivier, please, and just from the point of view of iXblue, which is such a forward-leaning company, Olivier, do you see regulation and the state of regulation at the moment as a hindrance and a blocker, or do you think that it's fortunate that it's a grey area and that enables you to get on and push the boundaries of your technology while the regulators catch up?
Yes, thank you, Nick. I'd like to thank you all for giving iXblue the opportunity to speak, and welcome everyone. So what we are doing at iXblue with respect to this question of regulation is two things. First was to give the access to the technology. And as Dave mentioned, right now you can use the DRIX, which is one of the unmanned surface vessels we have developed. You can use the DRIX from different ways, from the shore or from a vessel, a support vessel. Always with the supervising, autonomy methodology. What we do is to provide more reliability on the system and develop obstacle avoidance, surface obstacle avoidance, subsea obstacle avoidance, to ensure the good navigation of the asset and the integrity of all the elements around the unmanned surface vehicle. So we characterize the risk, and we try, from a technology point of view, to provide an answer on on all the question: what if we have one vessel coming in front of a DRIX? What if we have two vessels on the back? So what are the different scenarios that we should answer? Right now, I would say that all the technology, the camera, the LiDAR, the sensor are here, and the work we have performed is more on the artificial intelligence, on the software layers, and how we manage the different risk possibilities.
Brilliant, thanks. One of the questions that's come in is about standards. And Peter, if I could just pick your brains on this, do you detect concerted efforts across the industry, perhaps a little bit wider than just oil and gas, but into survey and the other sectors that I mentioned earlier? Do you see a concerted effort to set standards, because standards sit comfortably alongside regulation normally, or do you think the standards are lacking or lagging a little bit as well, please?
Yes, so I think that's an interesting one, Nick. I mean, I think standards, I'm rather hoping that technology will drive the standards in a way, because I think standards for individual companies that are operating in the maritime realm, whether they be energy or whatever, each company has its own specific standards, of which I think drives slightly different technologies. But I think, again, it's efficiency at scale. And I think with, potentially sort of the commoditization of this market, that, we will start seeing more standardization around a sort of, reliable product and package. I think GEBCO, obviously, I think is to some extent probably driving that as well. So maybe those combined efforts, Nick, will drive a more, not necessarily a harmonized, but a more standardized approach than we certainly have now.
Yeah, I agree, and I think the end users will eventually want better standards, because it makes their comparison problem a lot easier. Thank you very much indeed. That answers that question. Next slide, please, David, if you would. And I said I'd come back to COVID because there's a question saying, for all panelists, in your assessment, what is the extent of change brought about by the pandemic to the USV market? And just before I turn to you, Peter, because I think you have quite a global perspective as a result of your previous experience. I think perhaps the thing we have all learned almost in a heartbeat is that remote working is possible in our day-to-day lives. I certainly suffer from a condition known as Zoom eye at the moment. But have you seen this affecting the sector that you've just come from, and from your independent perspective, please?
Thanks, Nick. So I would. Oh, sorry, was that aimed at me, Nick?
It was. Yeah. Sorry, just a bit of a lag there.
Okay. Sorry, thank you. Well, I think one of the biggest barriers to uptake is actually cultural, and actually I think with COVID, and effective remote working now becoming absolutely standard across workforces, across all sectors, that actually I think the acceptance of the idea of supervised autonomous systems with sort of distributed remote operation centers controlling them around the world actually is no longer that fanciful an idea or that scary an idea. So I actually think in the short of it, that COVID has accelerated or will accelerate the acceptance, hence uptake and deployment of these systems. Also, thinking about the fact that these are unmanned, and there's an element of resilience in unmanned systems over manned with this current crisis. That surely has to have some impact on how these systems and offerings are perceived.
Thank you. And this is my chance to bring in Trevor. Trevor, I know you've been having comms problems, but you're the only panelist we've not heard from yet. You too have a very wide experience in in the sector. Perhaps could you comment on your thoughts on COVID and remote working, please?
Yeah, well, thanks, Nick. I think the situation here is it's given us huge opportunity to maybe bring in the technology at a faster rate. And looking at Peter's ex-company's target of remote operations by 2025, I think this is giving it impetus to get the technology into play, coupled with the logistic concerns we've got at the moment, not being able to move people around. So I think this can only benefit the overall situation, Nick.
Thanks, Trevor. No more on that, ladies and gentlemen. I think we'll now crack on to let's look at some of the technology, because that's what gets everybody excited. So next slide, please, David. A chance to look at the USV systems that are being deployed by Unique Group and iXblue. Next slide, please, David. And Trevor, Mike, back to you, please, to chat to your wonderful capabilities. Thank you.
Right. So when I joined Unique Group at the beginning of the year, we sort of had a strategy session. We've been dabbling around in ASV technology or USV technology, and we had to assess the market and where Unique could benefit, because we do not provide the surveys, we just provide the equipment enabling the acquisition companies to go out and survey. So we looked at it and said we're going to have a range of equipment. And as you can see on the screen there, 2 of our in-house developments. But we have to have a range of equipment because obviously nothing fits across the board. And once again, going back to Peter's words, that small is good to start with, and you can test a lot of equipment and then move through as you develop capability. So what we're developing within the Unique Group is what we're calling, well, we did call a Hertz model, but obviously Hertz have gone through some severe problems. So we're now calling it the Avis model, where the client can come to us, undertake very limited training, in some cases in Unipack, half a day. We certificate them that they know what they're doing with the system, and then they can take the system away on a trailer, go and do the work, and then bring it back at the end of the day. This is beneficial to the smaller companies who haven't got CapEx available to purchase the equipment, which ranges in the Unique portfolio from around $75,000 up to and including the iXblue Trix, which is a considerable investment. It's around €1 million by the time you've configured this thing up. So we have a production run of 10 Unipacks at the moment, with the first arriving in Holland this week, where I'm stationed at the moment on very limited bandwidth. But the intention is to move those around and have them available from the Unique offices globally. Now, just to give a quick indication on this, I'm not going to read out, and there are additional slides in the packs, but you're looking at, on the left there, the Unicat, a 4-meter system. On the right, the Unipack, which is a 3-meter system. Both of them can work into 0.5 meter of water. Both of them can take considerable payloads. In the case of the Unipack, 150 kilos. Duration of about a survey day. And at the moment, we're using these systems almost line of sight. So they can be operated via GSM or by marine band radio or Wi-Fi if they're within ports and harbors, etc. So that gives you a little flavor of where Unique are going. And in the technology section a little bit further, I'll expand on where we're thinking of expanding what we're doing. Thanks, Nick.
Thanks, Trevor. I just love the kit. The questions are rolling in. David, could you go to the next slide? There are a couple of questions referring to USV type operations, and also could we envisage operations with AUVs and UAVs? If you don't mind, ladies and gentlemen, I'll pick that up a little bit later on in the agenda, and I am planning on overrunning by 5 or 10 minutes. So I'll pick that up. There's also been a question about a dictionary or glossary of terminologies. I'm sure we can help with that offline, so we'll pick up on that. So now's my chance to give the floor to Olivier to talk about DRIX and iXblue's technologies. And while you're talking to that slide, please, Olivier, there's a question saying, could you talk about a case study or of the technology being used in the Middle East region, if you're able to do so, please?
Yes, thank you. So what we see here is a drawing of DRIX, which is a 8-meter long unmanned surface vehicle, 1.5 ton displacement, and is one of the range of unmanned surface vehicle iXblue has developed today. So I would like to share the experience and the key technologies needed to master and to be able to operate successfully a USV. And the first time you're going to see a DRIX at sea, you'll be amazed by its unique shape. Will be a wave purser, wave breaker. And it was designed in the idea of no man at sea. Actually, you know, when we started this development 3 years ago, we asked ourselves, why should it look like a conventional vessel? And these shapes gives many advantages, such as the stability at sea. This gondola that you can see, which is 2 meters located below the sea level, gives an exceptional low noise level ratio. So what is the direct impact in the day-by-day operation? It's a stable communication in harsh seas. So this is very important when you want to communicate, for example, with an AUV. It's extended performances of sensors. We measure an increased performance of, for example, multi-beam of 30% because of this very good low level of noise where the sensors, the multi-beam sensors are located. So the extended water depth, the extension in numbers of pings, and the extension in coverage. Also, we see by using this kind of shape, this kind of naval architecture, that we increase the autonomy, very low fuel consumption. And this is a topic we discussed in the introduction about the carbon footprint reduction. If we compare the use of a DRIX with a 27-meter survey vessel, we can measure a reduction by a factor of 50 the fuel consumption. So the shape, the naval architecture is definitely a key, but it's not the only point to address when you are designing a USV. The control command is also very important, of course. The reliability of the system is probably the top of the concern when you operate an unmanned surface vessel, and we have identified single point of failure and put a lot of redundancy in our solutions to address these points. The launch and recovery is also a very important issue. And here again, we have iXblue has proposed a solution to launch and recover rigs, but also over surface and subsea assets. So again, all the answers to the question, what if? I mean, these technologies are new. They are available in the market, but they are new. We every day ask ourselves the question, and our customers are asking ourselves the questions, what if? And how can we do this with unmanned surface vessel? So over the last 3 years, we've been operating rigs, and we have a numbers of experience globally. We have 9 systems now operating globally, which gives us a reasonable idea of such usage of such tool, and how and where did we operate it? What are the case studies, as you mentioned, Nick? We've been operating rigs in hydrographic surveys, multi-beam data acquisition. Right now, we are enabled to use it also on LUXO, geophysical site survey with side scan, magnetometer, sub-bottom profilers. And it has shown a lot of benefits, as I mentioned, on the carbon footprint, but also on the time saving. With respect to conventional method, we see that the return on interest here is 3 or 4 times faster than conventional survey platforms. Of course, you have to compare apples with apples, so it depends on water depth, it depends on distance to the shore, and many other logistical issues. But we can see in some of the application great savings.
Thank you. Really interesting technology. Could you, one of the questions that come from the floor, just to add to your final comment there, please, Olivier, is why is the follow me feature useful for survey vessels? Yeah, so thank you for the question. This, for example, was developed for tracking AUVs. So for collaborative work between unmanned surface vehicle and autonomous underwater vehicles. So we've been doing some operations in deeper water. So the rigs can operate in various water depths, I would say up to 500 meter, 1000 meter for multi-beam acquisition. But if we are looking into very deep water, we either need a larger unmanned surface vehicle to fit a bigger multi-beam antenna or collaborate with an AUV. So here we can say to the rigs, follow the AUV, track the AUV, or even follow a surface platform to go to the offshore site. Okay, cool. Thank you very much indeed. Lots of questions coming in as a result of Unique Group and iXblue commentary so far. Comments such as the description of the system is very clear, but would it be possible to provide more information about launch and recovery? Can they tow sensors, etc., etc.? Ladies and gentlemen, thank you for these questions. Would you please be so kind as to email the panelists on completion of the presentation? We will put their addresses up and you can get more detail. And as I said earlier, there are lots of additional slides in the pack that may be helpful to you too. Please don't think me rude, it's just in the interests of time. Next slide, please, David. And whilst the slide is coming up, ladies and gentlemen, just a reminder of the survey, if you have the time, please. Thank you. So now looking at future developments and new technologies, these technologies we've just been talking about are pretty much the future and pretty new. But this is where we start to tease our panelists and ask them to look into their crystal ball and what's coming online, and what, whilst they're going to talk about their companies, they'll also be looking more broadly across the sectors and the technology as a whole. And in particular, gentlemen, as you respond to this, could you please comment on how you envisage accommodating multiple USVs rather, maybe multiple AUVs, or working with AUVs and USVs, and maybe even with UAVs, to me, these are all autonomous systems and they can also be used. And the other thing, of course, is they can be used with manned platforms. So it's all about force development and maximizing the benefit of bringing lots of technologies to bear and lots of platforms to bear. So next slide, please. And this is a chance for Olivier, mindful of that scene setter I've just given you, please, to comment on addressing challenges and future opportunities. Thank you.
Yes, thank you, Nick. Maybe I will try to answer a few of the questions that you bring. Right now, where we are is with DRIX was really to enhance the scope of work of the assets. So as I mentioned, you can integrate into the DRIX a set of various sensors, multi-beam, sub-bottom profiler, side scan sonar, magnetometer. But we want to go beyond. One of the points was to use multiple DRIX systems. So this is done today. I mean, we have a customer as we speak who operates 2 DRIX with multi-beam at the same time. And we believe that with a crew, a supervised crew of 2-person, 3-person on 24-hour shift, we can supervise 3 DRIX at the same time. But if we go beyond, what are the topics that we are working on is go deeper. So go deeper in multi-beam acquisition data is to enable to launch and recover subsea assets. So how should we operate when we want to operate ROV for inspection, maintenance, and repair? All these elements, we cannot answer them with DRIX. So this is why we created a range of solution with some catamaran, autonomous catamaran, 25-meter catamaran that enables to launch and recover subsea assets. So it could be AUV, big AUVs, or world-class ROVs. This is something that is not produced today, but is designed. Studies have been made on that. And there is a lot of development ongoing with respect to these technologies. The key here, again, I think we shouldn't underestimate the naval architecture design, the stability of the assets in order to properly launch and recover, and also the communication. Cyber security is also a key domain in which we are challenged every day at iXblue in order to do the operation today as unmanned as possible. Unmanned means unmanned offshore, of course, it doesn't mean unmanned onshore, and it will also create a new set of skills and profiles for in the industry in order to be able to supervise these assets remotely.
Very good. Thank you very much indeed. And just on the questions, these more detailed questions, just from Ria amongst the organisers, it is possible for us to arrange one-to-one meetings between the attendees and the panelists. Please do tell us your interest when you answer the survey, and we'll make those arrangements. So now, next slide, please, David, and a chance for Trevor to comment on some of the forward thinking amongst Unique Group. The floor is yours, Trevor.
Yeah, well, thank you, Nick, and thanks, Olivier. The DRIX has got many potential opportunities. When we took delivery of the first one, and we're taking delivery of our second one the beginning of 2021, we thought we knew what it was going to go out to do. And we've been amazed with the requests coming back in from industry. So the force multiplier, I used that in a previous life with Ocean Infinity, where we had up to 9 AUVs in the water at any one time. So this is becoming standard practice now, the ability to cover large areas. But if I sort of change tack a bit here, Unique Group, obviously, we're always looking at the next opportunity and where we can fulfill our clients' requirements. And as soon as we built UniCat as the prototype and then developed that, we learned from that, and we developed and produced UniPack. which is our 3 meter by 1.2 meter long version. That grew arms and legs, and all of a sudden it became a 250 kilo package by the time we put payload into it. So the next thing we did was we said, right, we're going to go half the size. So we've now come down, and the restraints on Uni-Mini are that 2 men can pick it up and pop it into the water. So Uni-Mini will be a development coming out by the end of the year. As part of this development, we've already undertaken station keeping, and we will develop that up onto Unipact as well. So you'll be able to go out and loiter over an area. For example, you might want to do a bridge or a tunnel survey where you're taking bathymetry as well as LiDAR above the waterline. So you're getting the complete package. Next slide, please. And then, of course, we're moving out. When we took DRIX, we looked at gliders. We represented a couple of companies in the markets, gliders, through Unique Group. But now we have an opportunity to take a hybrid surface glider, which can also submerge. So this is a system coming out of the USA, which we're in discussions with at the moment to represent, where it has the capability of diving to 200 meters below the water surface and then coming back up and self-powering itself. Obviously, at this stage, there will be limited payload capability on it, but the technology is there. So in defense purposes, it will be used to move under the weather, to go and to be subservient, or to go over and do secure operations. And coupled to this, and in the slide pack, we also are looking at the moment to a tethered drone. And we're using the tethered drone to extend the range of operations for the vessels outside line of sight at sea level. So, for example, we can go from an 8 to 12 kilometer range with radios that low in the water. As soon as we move one of the radios up to 200 feet, 80, 90 meters, we can extend the range of operations to over 30 kilometers. You may say, why do you want to do that when the satellite's around? Once again, it's either cost or it's in an area of the world where there's no infrastructure. It's okay in Europe to go around and operate systems with 4G or with Wi-Fi, but we've just been undertaking a project in the Red Sea where there was no infrastructure at all. So that just gives you a little flavor, I think, of what we're looking at within the Unique Group. But please, if people out there, if you've got a requirement or you've got something you feel that we're not addressing, please get in touch with David and myself, and we'll take a good look at it. Thank you, Nick.
Thanks, Trevor. I just love this one. What a wacky bit of kit that is. Very exciting. Just going to broaden the debate a little bit now. Could you go to the next slide? So we're sort of into broader Q&A, and then next slide as well, please, David, which will put up panelist details for people to see. And as I mentioned, please do go through the surveys to arrange meetings with the panelists. But there are various questions rolling in, and David and Peter, I'm coming your way with these. This one is, what would be the next big thing in the USV market? I think I'll just say it, broaden that to autonomous. Where does the industry stand when it comes to digital transformation trends that currently creates waves in other industries, such as those caused by the pandemic? There was a bit of a lead in there from Trevor, David, about connectivity, and clearly this is all about getting sensors and data back to shore. Whilst the bits of equipment are very exciting, the platforms, actually it's about the sensors and it's about the data. And Peter, you talked about data as a service. So David, looking into your crystal ball, what do you think will be the next big thing in autonomy? And after David, we'll go to Peter. Thank you.
Yeah, I think the data links are one of the critical areas that will need to improve to really take full advantage of over-the-horizon operations, because we have the capability already to run a USV completely out of sight, globally, but you can't get big data sets back from the vessels. So that's one of the main challenges. And there's some other sort of physical challenges with things like side scan systems. They really need to be towed at a certain level above the seabed. So, and you can use AUVs to achieve that in deeper water, but they have battery life constraints. If you use a surface vessel, you either end up pole mounted, so you're subject to wave motion, and you've got very limited depth capability, or if you to try and tow stuff from autonomous vessels, that's not really practical yet. Although I know iXblue are working on a system that should allow side scan and possibly magnetometers to be towed from a DRIX. But these are areas that we get asked a lot about, whether you can tow a side scan and whether you can tow a magnetometer. You know, a lot of offshore wind farm development, particularly around the UK, requires extensive UXO clearance surveys, which need gradiometer arrays and very tight line spacing because the detection ranges are very low, and that's extremely difficult. Well, it's extremely onerous to do. They spend a lot of time doing these surveys, clearing these large areas, and that seems like a prime area that force multiplier of multiple USVs covering the area quickly. There seems to be big gains potentially to be made there. However, one of the differences is we can't get tow magnetometers close to the seabed from them.
Thank you. David, just while Peter starts talking to this question as well, could you just go back to slide 3 so that the audience can see the handsome features of our delegates? Thank you. Thank you, Rich, indeed. Peter.
Extremely flattered there, Nick, on all our behalf. I think, there's going to be more, this is turning from a pavement to a motorway, to use an analogy. I think the next big things are going to be really interesting. Again, what we've seen here today. Bigger doesn't necessarily mean better. So I think we're going to see a profusion of smaller bespoke systems, specialized systems that show efficiencies for specific tasks, and we'll get more diversity in the smaller units. I think on the larger side, and Olivier again was talking to the 25-meter plus kind of size vessels, then obviously when you're into that kind of size, then you want to do some level of intervention or have a capability for intervention. So I see the extension of ROV, AUV launch recovery systems on larger unmanned surface vessels, becoming a big thing. But also, a profusion of different kinds of exotic species of smaller unmanned systems that actually have their own niche for specific data collection. And I think that's probably going to kick in from next year onwards at scale. Cool. It's a very exciting time.
Good, it is exciting times. Another question from the audience, and I'm going to come to Trevor and Olivier and Peter on this. What are the cost savings for using a USV against conventional methods? And I guess this is around the shallow water sort of capability we're talking about. So have you done, Trevor, Olivier and Peter, comparisons of manned versus unmanned costings, please? Trevor.
In terms of our smaller vehicles, I think it's just the ability not to have people in the surf zone or working in dangerous environments near to dams or water intakes. So I think from a pure survey point of view, surveying at 4 knots is 4 knots. However, yes, there's a force multiplier and you can put more in. But as you move up the food chain and move into something like DRIX, I think that's where you see significant savings. And Olivier, I know you've done quite a lot of work on this in terms of looking at how quickly or how much more efficient you can be by using either a mother vessel coupled to a DRIX or a mother vessel coupled to 2 DRIX. So Nick, I'm not sliding out of this, but I'll push it across to Olivier, if that's okay.
Thank you, Olivier.
Yes, thank you, Trevor. Nick, should I the answer?
Yes, please.
Yeah. Okay. Yeah, indeed, Trevor, you are absolutely right. We made some side-to-side comparison, and this was done in the northern UK a couple of years ago already, between a classical survey launch and a DRIX on multi-beam data acquisition. In shallow water, it was 100-meter water depth, and it was close to wind farm. What we saw is at least 3 big differentiators between the 2 assets. The first one was the line keeping. Because of the automated software, we see the DRIX could keep very well his line actually, and the captain on the survey launch was struggling with a side current, and we see a saving on the light keeping. Then the turn radius was also a point. You will see a turn radius of 17 meter on DRIX, 17, which is very efficient. And the third point was the speed of survey. We could acquire the data sets up to 8 knots. And the sum of these 3 advantages led into 3 to 4 times faster survey data acquisition, favoring the DRIX compared to classical methodology. Again, here, this is an example. I'm not saying that all the survey will be done in 3-4 times faster, but it gives an idea on how efficient can be a survey done with an unmanned surface vessel like DRIX.
Brilliant. Thanks, Olivier.
I think I'll just jump in, Nick,
Yep.
is the one point also that DRIX has a huge advantage as, when you're doing wind farm surveys, you would do a 200 meter by 200 meter area, then move a kilometer away to the next area. And the transit speed of DRIX between 12 and 14 knots makes a significant difference throughout the day.
Brilliant, thank you, David. Peter, just before you comment, David, would you please mind stop sharing screen now? I hadn't realised that. There we go. Now we can see the handsome chaps there, apart from Trevor. Brilliant, thank you very much. So, Peter, your chance to have a go at that question, please. Thank you very much indeed.
Thanks, Nick. I think it's mostly been answered actually by David and Olivier, but I mean, I think, obviously one of the most obvious comparisons around cost is the manned versus unmanned day rates. But I think, alluding to what was being said earlier, actually value as opposed to cost is where we should be focusing. And actually the value of better data, the value of better risk management, the value of being able to conduct these things with increased safety. I mean, I think for me, that's where the sort of it should be a value rather than cost discussion. Like for like is interesting, but better than like for like is where we really want to be. And I think, the examples already given, demonstrate that in buckets.
Yeah, thank you. And that's just leads nice segue into another question here, which is talking about the policy and legal ability to operate surface vessels with crewed vessels and so on. And I guess there's a combination of vessels that might be working in tandem on a particular task or operating autonomous systems in the vicinity of transiting manned vessels. So a bit of a conversation around that would be helpful, but please also add to it this business of unmanned, which I said I would pick up on, Peter, from your very first slide, or second slide rather, which is, it's all very well saying we'll have 0 people at sea, but these systems are complex. They're a mixture of salt water and electrics. Systems do break down. So just a commentary, perhaps, please, with starting with you, Peter, and then we'll go to Olivier and then to David. Just talk through your experience of these operations and how complex it is, and do we really see completely 0 manned vessels, or is it going to be a different kind of support?
It's a really good. I'll be brief, Nick. I think from a sort of operator perspective, all we want is the data. So as long as you have persistent presence and you have an ability to call off, then really, from an operator's viewpoint, that's all they're really interested in. If it's done unmanned, that's the objective. And certainly, you know, unmanned, getting people out of harm's way, or uncrewed, sorry, rather than unmanned, you know, is definitely the next big thing that I think is going to reduce or improve the offshore safety statistics. So I think there's a big sort of political play there around improved safety that drives a lot of this. So I don't know if that answers it, Nick, but you know, it's certainly worth consideration.
Thank you. Good perspective, Olivier.
Yes, what I can talk about is the experience of what we have with what we have done. You know, today we have rigs in the water operating at sea on a 24-hour, 7 days operations, and we have faced issues. We have had downtime, but not more than 1 day, and we can say and prove that the impact of man at sea was absolutely negligible. And this is with using a DRIX. It's not with using an unmanned surface vehicle that launch and recover world-class ROV. That will be a different story. We are working on that. But everything is in the risk management, in the risk assessment. Really, we are working a lot on that. On DRIX, we identify single point of failure. We provide a lot of spares. And we try to put redundant systems. All the time, we are in redundancy in everything we do on the DRIX and also in the future designs that we have, that we're working on. Sorry, I think I was interrupted in my video. Sorry. So this is the answer. I think on DRIX, today, we see a very little impact of man offshore, almost to say nothing. For the future concept of launching and recovery assets, that will be that we need to carefully look at that. It will be another story. We all know that you have recurrent maintenance on ROVs, and this will have to pay attention. When we are working with DRIX today, we advise a regular return onshore, which is a few days, like every 5 days, we have to return onshore for a check, for a maintenance. This is how we operate.
Thank you. David? And then we'll give the final word to Trevor. Thank you.
Yeah, Olivier covered some of my concerns with completely unmanned operations. Now, if you have a self-contained vessel like the DRIX on its own, or one of the unique Unicat or Unipact, it's reasonably easy to operate that autonomously with nobody on board and no intervention. As soon as you start adding ROVs or towed systems, you've got cables, you've got connectors, you've got mechanically moving parts. If you're launching and recovering AUVs from a vessel, it's the same issue, and these require maintenance. That there will be minor faults that you just need someone to unplug a connector, clean it up, and re-grease it and plug it back together. That's difficult to do without someone available. So that's a challenge going forward, and maybe that'll be addressed by operating in the vicinity of a mothership that's performing other tasks. So you're getting a force multiplier benefit. Using multiple autonomous vessels from one support vessel gives you big cost and efficiency savings, and you then have the capability to make corrections. And if we go to towing systems, I've done a lot of side scan over the years ago when I worked at GSE, and static fishing gear is a significant issue. These are things that are very difficult to control autonomously. The environment's very fluid, so fishing gear, snags when you're towing equipment, those are going to be issues to overcome.
Thank you. Trevor, your experience, please.
I think, and sort of coming from a previous employer where we had many days of deliberation and strategy sessions on truly unmanned, and the feeling was that, as the other presenters were saying, certain operations cannot be undertaken totally autonomous at the moment. So we had a situation where we had bolt-on accommodation units to a totally autonomous vessel for undertaking ROV operations. But ROVs, I think over the next 2 to 3 years, and primarily because it was BP pushing them along, are becoming autonomous. And I think you'll see, although 2025, I think, was a real stretch, and it was mocked by industry when it was first brought up, Peter, but I think slowly you've got a situation where you're forcing the contractors to move into that direction. If you put 2050, everyone would have done nothing and happily worked through their career and retired. So I think putting the 2025 out there was probably the best thing for the marketplace. And then I don't know if BP contributed to COVID. I'll leave that for speculation and another time.
Brilliant. Gentlemen, it's been such a good session, a real tour de force. Thank you very much indeed for taking us through everything from tackling the big corporates through regulation and standards and thorny issues like coal regs, showing us some exciting technologies for above and below the water and giving us the benefit of your considerable experience. It's been a real pleasure to be back in touch with you and to work with you on a webinar like this. Of course, the bit I'm going to hand over to Firas to make some closing remarks on behalf of OI in just a second, but the bit that is missing now for me, if this was a proper conference, is we'd all be giving you a proper round of applause, which is what we should be doing, and then we should be gathering with either a glass of wine or at least a cup of coffee and having a good old chat with the attendees. And so it's my chance also, if I may, as the moderator, to thank the audience for joining us. We've had some very good numbers. What a lovely audience you've been, and some cracking questions. I think I have answered, or we have answered, just about all of them. But as I said, there's a survey and the chance to meet the panelists in separate meetings arranged by the team, and also to email them. And finally, big thank you to Boomi, who's put a huge amount of effort into this, Ria, and to Firas. So, gentlemen, perhaps we should give them a quick round of applause to thank them very much indeed. And Firas, over to you to close. Thank you.
Well, Nick, thank you very much. It was a great session, and we look forward to coming sessions as well. Thanks for all the attendees. Please be reminded of the Q&A session. Follow our LinkedIn page and register your interest in our website. We have some more interesting topics coming up. Again, we are delighted to have you all. Nick, thank you very much. Uni Group team and iXblue team. Thank you very much, Peter, as well. Well, until next time, this brings it to an end. Have a wonderful day ahead.
Thanks, Firas. Good luck, everybody. Bye.
Thanks so much, Joel. Thank you.
Bye.